Yeah, so this is lithium iron phosphate battery, LFP, lithium iron phosphate battery I made for my 150cc Yamaha SZ-RR bike. This is earlier lead acid battery. Weight is like almost 80% of this one, and size wise length is high, but thickness is lesser than this. And I was able to mount it on that. I'll show that. So previous video I showed I used a 4S 100 amps diode, BMS 4S 100 amps, and on shorting it had gone bad. So this time I used this diode scheme, which I have shown in my previous videos also. That means this 10 diodes are there for discharging. They are connected to the P minus of this point, P minus, this point to the negative of the battery, this point. This is one thing, and other is this battery negative point is there. So again a 10 ampere diode connected to the negative of the battery, again same point to the negative of the battery. So this is to make sure that only while charging the BMS is used, and this is to ensure that all the discharge is happening from the diodes. This 10 into 10 ampere diodes. This is ensuring that it will happen by this only, not that parallelly this will do the discharge. And Kapton tape has been used. This kind of barley paper, Fisher paper is used. Barley paper. And then this capacitor is used between the final outputs. That is a P minus and the P plus. P plus is same as B plus. Compared to lithium ion battery, here you have to use 4S configuration or getting 12 volt of bike. And also the energy density is slightly lesser in this LFP. This is 15Ah battery. Each of them is 3.6 volt, 15Ah. The pack is 15Ah, 14.4 volt, 3.6 15Ah, and 4S will be 14.4 15Ah. But it is said to be safer compared to LFP because it does not produce its own oxygen if fire is happening, and also the charge cycles are very high compared to the other one, lithium ion. This will last at least 6-7 years of good use. So with this lead acid battery I was looking for a liquid one, not the sealed valve regulated or AGM, because they go bad in 1 or 2 years, and if you're not using it will go bad in 6 months only, new battery. That's why I was looking for something which will be sturdy. So this is like 5Ah and this one is 15Ah. I have to do some packing and all final. Here, this kind of strap was used for mounting this battery. I extended it a bit by connecting by making this kind of hook, because this battery size is big. Here binding wire is used, which is steel wire used in construction work for tying together the rebars, steel reinforcement bars. They are tied together with this one, so it has to be painted, otherwise rust will come. So this will be used for mounting this to the bike. Also, this capacitor I told, it is for taking the spikes, for saving the BMF if some spikes are there. So its actual value is 1.5 microfarad, using two polar electrolytic capacitors connected back to back, which I mentioned earlier also, to make it non-polar. That means the two negative ends you have to connect and the two positive ends will become polar when you connect the two negative ends, and the capacity will be halved, capacitance will be halved, the voltage will be same. It is connected across the output P plus P minus. See, that battery is put, and now I'm able to close this properly. This bike has lot of starting problems. For first time when I started after 3 years, took more than 1 hour to kick and start. That's why I put big battery. I have mounted this carriage back, that's why it's difficult to remove. Yeah, you can see I connected the negative terminal, positive terminal wrapped it. This thing extended. This is metal wire. This thing has been put so that it does not cut the battery. Hooked it here. It's quite stable. What problem now I'm facing is bike is not turning on. Spark plug is coming, self and all is working. I watched it actually. This bike has a lot of starting problem. Spark plug is coming, I removed and saw. So the battery is success. Yeah, so I will show it after it is started.